Okay, as Jerry mentioned, I'm Tram Chase. I'm from SimVentions, and it's gonna be kind of a roundabout story, but hopefully you'll stick with me. And talk a little bit about how making things work together is really hard, and kind of from a software perspective, and then how we kind of made some things a lot easier in the software world, and how that applies probably to your embedded systems. So first we have to go way back in history. So my first kind of real job in 1995, I worked on the Navy's Aegis segment for the Theater Missile Defense System Exerciser. And the idea was we had all these great weapon systems in the DoD, and we needed to put them together so we could shoot down missiles from the enemies. So my job was to hook up an existing Aegis stimulator to a Patriot missile launcher and a THAAD launcher and all these other systems. And we were given a big, thick document called the DIS standard, Distributive Interactive Simulation. And in that document, there were a bunch of message formats described and some sequence diagrams of how these messages were supposed to be used. So we, the Aegis people, went off and built a little adjunct processor, it was called, that took the Aegis messages and sent and received those through this DIS network that we built with all these other systems. So we went off and built that. Several months later, everybody gets together and we bring up this big network across the country. And down in Huntsville, Alabama, there's a scenario driver. So they play a script and missiles fly across the screen and all the systems are seeing the same picture. And it might be 20 seconds, it might be 20 minutes, but inevitably you got the phone call and someone said, okay, we had to stop. So that meant somebody crashed or didn't respond to a message, just did something wrong. And I can't speak for any of the other nodes around the country, but I know at our node, it kind of looked like this if you were in the lab. So we ran around, we checked log files, we restarted systems, we wrote new code right there on the fly, recompiled or restarted everything and said, okay, try it now. Now we did this lots of times. 15, 20 times a night, and this lab was expensive, so it cost a lot of time and a lot of money. But we got there. It eventually worked. We were successful. They called it successful, but it took a long time. So I guess I totally forgot what I was going to say next. So one of the reasons that it was really hard, I feel, was we were given that document. We were very document-centric. All we cared about was what was in those pages. And that promoted a lot of bad habits, I think. So each of the segments went off and they read that document and they built their solution. We all interpreted the message formats and we all coded those. We wrote behavior in our code. We did all of that independently. At a minimum, one of us should have at least put all of those messages into a library that everybody could use. So when those messages changed or somebody did something wrong in that library, at least everybody did it wrong all at the same time. But when changes came along, everybody had to update. So there's a lot of stovepipe solutions and workflows that had to be repeated over and over to make it work. You also couldn't find information quickly. The DIS standard had the message formats, but if I wanted to know what enumerations go in certain fields, I had to go find another document. And if I wanted to know what format my coordinate system needed to be to transmit the location of my ship or my missile interceptor, I had to go look for the WGS84 standard and implement all of that into my code to make sure I was sending good messages. And then you have data all over the place. So we had the DIS standard that had the message format. Then we had our Aegis segment ICD where we copied all those messages into that and said, this is how we play in the games. And then we had a C++ header file that had that message format in it. So let's update that 3 times every time that message changes. And all this leads to a bunch of mistakes and having to redo things in that lab night after night. So a lot of problems there. And now, are we any better at it now? Probably. We still have a lot of documents. In this case, the simulation world moved on to the high-level architecture. So they basically created an object model where they could describe all the objects and entities in that simulation and distribute that so you could load that into your simulator. So at least everybody had the same data, same look at what was happening. But we're still very document-centric. So now I'm working on an SBI, or a small project related to the host program. And we're trying to build tools to make integration easier. And we are here for the tri-service or open architecture interoperability demonstration tomorrow. So we were here in December for a dry run and make sure everything was working. And as we were setting up our table, and there were several other vendors setting up tables, and I was watching everybody else. And someone had a development backplane chassis thing. I'm not a hardware guy. And they had some modules in it, and they were testing things out, and someone else said, hey, let's stick this one in there. It should work, right? It's going to work because the documents say this matches this and all that kind of stuff. And so they do that, and that's what you get with hardware, right? It wasn't exactly this, but it didn't work. So the exact same problem. So they pulled the card out, stuck it in a different slot, and said, okay, try it now. So we were right back to where we were 25 years ago, saying, okay, try it now. Now, how can we fix that? As I alluded to, there are new standards. There's great groups like SOSA, everybody trying to fix these things. We're doing it better, faster, smarter, cheaper, frameworks, architectures, all of that's great. And that project that we're working on to build a tool to help make integration easier really relies on data. So your tool can't read the document and do things. You have to put data into the tool or embed all the smarts and the engineers into the tool. So what we need is to be more data-centric versus document-centric. Once you turn all your data into fields that describe the objects and the attributes of those objects, whether it's modules, backplanes, mezzanines, whatever, you can then build a lot of things. You can build repositories. So if I need to replace a module, I can go to that repository and I can search on some criteria and it'll tell me which cards I can replace that card with. I can generate the documents. We shouldn't be writing the document and then putting that in code. It should be the other way around. And you can build a lot of cool things for modeling, analysis, and simulation. What if you could have a navigable rendering of a backplane, click on one of those slots, and then you get a profile diagram, and then you can click on the little segments in that profile diagram, and then you get the tables that tell you all the signals. That's a little easier than going through the Vita documents and finding tables and then finding other documents and finding tables. And you can automate a lot of this. Testing, conformance, all these things can be fed by data files that could then be used to evaluate your hardware, which ultimately leads to hopefully doing all this faster, better, cheaper, smarter. Okay, so the last, okay, try this now. So just a suggestion here. Collaborate, build a data model that describes all your hardware, your modules, your backplanes at an abstract level, so you can do this, and then that will enable tools and repositories and data exchange across companies. Everybody's going to do this, interpret Vita 65 and paste it into a spreadsheet, and you're going to have a different spreadsheet than this guy, or you're going to have yours on sticky notes all over your cube. Use things that you can share. So I think that's it. I'll be at the Tri-Service or Open Architecture Interoperability Demonstration tomorrow if you want to come by and see what we've built to try to do some of this to make it a reality. Or you can catch me afterwards if you want to chat about it. Thank you.